at a limit function. Let's say we have a limit x approaches 0, evaluate tan of, evaluate when limit approaches 0, tan of x, tan x. Okay. Here what you can do is you can try substituting tan x, 0 for tan. That's actually 0, so this is a direct substitution. We don't have to do anything else. This is our final answer. Now let's try this one. Let's say we have a function given like limit x approaches 0. Now let's limit x approaches 5 by 2, 5 by 2 tan x. Tan 5 by 2 is undefined, so we cannot directly plug it, so we have to do something else. So what we can do is we can look at the left side and right side and see what we are getting. So let's look at the right side first. Limit x approaches 5 by 2 from the right side. So 5 by 2 is basically 90 degree. Okay, so we are gonna get some values that is close to 90 degree and see what we get. So if you plug in like tan, and also if it's approaching from right side, it means it should be greater than 90 degree. The value we take should be greater than 90 degree and close to 90. We can try 90.1, and if you plug it in this one in the calculator, you will get negative 573. And then we can try another number that's even closer than this to 90, like 90.01. that gives us negative 5730. So you can see as the tangent get closer to 90 from the right side, we are the y values getting closer to negative infinity. So we can say this is negative infinity. And let's try the limit x approaches 5 by 2 from the left side for tangent x. Okay, left side, when the x approaches 5 by 2 from the left side, it means we have to have a value that's less than 90 but close to 90. So we can try something like 89.9, something like that. So tangent 89.9. If you plug it in the calculator, you get positive 573, and you can even go closer than this, like taking tan 89.99999 like this. That's going to give you 507.30. What just happened? Okay, you know what, I just accidentally scrolled it. Okay, here we go. So that gives us like 5730. So you can see as the tangent as the x become close to 90 degree from the left side, the function goes close to positive infinity. It converges toward positive infinity. So from the right side we are getting negative infinity, from the left side we are getting positive infinity, so we don't have the equal answer for both of them. Therefore the limit x approaches 5 by 2 tangent x does not exist. Okay, let's look at another problem. I'm gonna go ahead and erase this one, but before I go to that, I can also give an explanation for undefined for the tangent 5 by 2. Like, how do we know tangent 5 by 2 is undefined? The easier way you can see it is you can write tangent 5 by 2 like sine 5 by 2 over cos 5 by 2, and you know that sine 5 by 2 is 1 and cos 5 by 2 is 0, so that gives us undefined, right? That's the one that's why we couldn't directly substitute in the last problem. Now let's look at the next problem. Okay, let's say we have a question like this. Limit x approaches 0 from the right side. What is the cosec x value? Okay, now here is from right side. It means the value we are getting for 0 should be greater than 0. And also, let's see what happens if you directly substitute. Like cosec x is basically 1 over sine. Okay, 1 over sine x. 1 over sine x is cosec x. So if you plug 0 for this, it's 1 over sine 0. Sine 0 is 0. 1 over 0. So that's undefined. So that's why we cannot directly substitute here. So we have to do something else. So we can take a value that is close to 1, but it should be greater, close to 0, and it should be greater than 0, and it should be close to 0. Okay, so if I take value like cosec 0.1, that will work. If I take cosec 0.1, then that is basically 1 over sine 0.1. So that is 1 over sine 0.1. And if you plug sine 0.1 in the calculator, you get 0.1. So this is going to be 1 over 0.1, that is equal to 10. And if you take 0.01, you get the 0.01 here in the denominator as well. That goes to 100. And if you take 0.001, that goes to 1000. So you can see as the signs, as the function x goes close to 0 from the right side, this function is converging toward infinity, positive infinity. So the answer is positive infinity. And that's it for this video, guys. Thanks for watching. See you guys on my next video.